Hello, I am Geeta Babu Singh, welcoming you all again to this session. In previous session, we discussed session layer, presentation layer and application layer. In today's session, we discuss on TCP IP, internet addresses and repeaters. Let's see the relationship of layers and addresses in TCP IP. As shown in the block diagram, starting from the physical layer, which is nothing but the first layer, the physical layer and data link layer. At the physical and data link layer, TCP IP does not define any specific protocol. It supports all the standard and proprietary protocol. A network in TCP IP Inter-network can be local area network or wide area network. Physical addresses, as shown in the block diagram, physical addresses are known as the link address is the address of a node defined by its LAN or WAN. It is included in the frame used by the data link layer. It is lowest level address. So let's see the next one, that is network layer. At the network layer, TCP IP supports the internetworking protocol. IP in turn uses 4 supporting protocol, that is ARP, RA, RP, ICMP and IGMP. In network layer, internet working protocol, that is IP, it is an unreliable and connectionless protocol. A best efforted delivery service. IP transport data in packets called data and grams, each of which is transported separately. Address resolution protocol is used to associate local address with a physical address. Reverse address resolution protocol allows host to discover its internet address when it known only in its physical address. And the next one is that is Internet Control Message Protocol, ICMP, is a mechanism used by host and gateway to send notification of data gram problems back to the sender. ICMP sends query and errors reporting messages. Internet Group Message Protocol, that is IGMP, is used to facilitate the simultaneous transmission of a message to a group of recipient. The next one is the next is your logical address, as shown in the block diagram, are necessary for universal communication that are independent of underlying physical networks. The logical address in the internet is currently a 32-bit address that is defined by a host connected to the internet. No two publicly addressed and visible host on the internet can have the same IP address. So next is our transport layer. In the transport layer, traditionally the transport layer was represented in TCP IP by two protocols, TCP UDP and SCTP. IP is host to host a protocol. UDP and TCP are transport level protocol. User Datagram Protocol, that is UDP, is a process to process protocol that address only port addresses, checksum, error control and length information to the data from the upper layer. Transport control information Transport control protocol provides full transport layer service to application. It is a reliable stream transport protocol. A sending end TCP divides a stream of data into a smaller unit called segment. At the receiving end, TCP collect each datagram. Stream control transmission protocol provide support for new application. The next one is our port addresses as shown in the block diagram. The IP addresses and physical addresses are necessary for quantity of data to travel from a source to the destination. The last is nothing but our application layer in TCP IP is equivalent to the cabinet session, presentation and application layer in the OSI model. And the specific addresses as shown in the block diagram. Some applications have user friendly addresses that are designed for that specific address. For example, email addresses. As shown in the next slide, we have the addresses in TCP IP. The addresses are of 4 types. First one is our physical addresses, logical addresses, port addresses, and fourth one is specific addresses. Let us see the physical addresses. As shown in this block diagram of physical addresses, we have the sender side in which the data is nothing but our source address and which has the code that is 10, and destination address is 87. So we are sending our source address to our destination address. As shown in this circuit block diagram, so we are sending all these messages through lane. So we are sending our data to our destination, that is 87. So first the source sends the address and it checks its address, destination address, that is 87. When it reaches to other systems and when it when it checks its destination address, and if no matches happen, then that packet is dropped and it goes on. Then it reaches to its destination address, that is nothing but our 87. So next is our IP addresses, in which we have the so next slide is our IP addresses. As seen in this slide, we have the block diagram of IP addresses, in which the computer with the logical address A and physical address 10 needs to send a packet to the computer with logical address P and physical address 95 as shown in the slide. The sender encapsulates its data in a packet at the network layer and adds 2 logical addresses, that is A and P. The network layer consult its routing table and find the logical address of the next hop, that is router I. To BF, the router 1 that corresponds to the logical address of 20 The network layer passes this address to the data link layer, which encapsulates the packet with physical destination address 20 and physical source address 10. The router decapsulates the packet from the frame to route the logical physical address. The router consult a routing table and ARP to find the physical destination address of the next hop, that is router 2. The source physical address changes from to 99. This is nothing but our work which is done by the IP address. Next, see the port addresses. So next slide is we have the port addresses. The port addresses is nothing but the IP addresses and the physical addresses are necessary for quantity of data to travel from source to destination host. So as shown in the slide, we have the data uh, that is from sender side we have the data that is which is on our application layer. Then it transfers our data to transport layer. Then it passes the data to network layer. Then it passes the data to data link layer. From data link layer, the our data is transferred to internet. Through internet, our data is again transferred to T2, that is nothing but our data is transferred through internet to data link layer, then to network layer, and then to transport layer, and lastly application layer, then lastly to the receiver. This is nothing but our port address work. So next slide is same as our same as shown in earlier slide, that is a relationship of layers and addresses in TCP and TCP IP. So next one is in next slide we have the 5 categories of connecting devices. That is how we are connecting our devices. For that we are using 5 categories. First one is our passive hub, second one is a repeater or hub, third one is bridge or 2-layer switch, fourth one is our router or 3-layer switch, third one, last one, that is fifth one, is nothing but gateway. So let us see a repeater connecting 2 segments of a lane. So as shown in this slide, we have the two systems, that is system 1 and system 2, connected with the help of a repeater. So a repeater is a device that operates only in the physical layer signal. Signals that carry information within a network can travel a fixed distance from attenuation endangers the integrity of data. A repeater receives a signal and before it becomes too weak or corrupt, regenerate the original pattern. The repeater then sends the refreshed signal. A repeater can extend a physical length of a lane as shown in the a block diagram of a repeater connecting. So next in the next slide, here also we have a repeater does not actually connect two lane. It connects two segments of the same lane. The segment connected are still part of one single lane. A repeater is not a device that can connect two lanes of different protocols. So as we study in the earlier slide, where we are connecting two repeaters with a segment 1 and segment 2, so that our repeater actually connects two same lane systems. So here a repeater can overcome the 10 base 5 or Ethernet length restriction. In this standard, the length of the cable is limited to 500 meter. To extend this length, we divide the cable into segment and install repeaters between the segment. The portion of the network separated by the repeaters are called segments. The repeaters acts as a two-port node but operates only in the physical layer. When it receives a frame from any of the port, it generates and forward it to the other port. Let's see the function of repeaters. So as shown in this slide, we have the block diagram in which generated signal, the middle is the repeater, and next last one is the corrupted signal. That is nothing but right to left transmission. In the second block diagram, we have left to right transmission where corrupted signal, repeater and rectangular signal. The location of a repeater on a link is vital. A repeater must be placed so that a signal reaches it before any noise changes the meaning of any its bits. A little noise can alter the precious of bits voltage without destroying its identity. Thank you.